Today I'm going to be going over the projectile motion where we have projectiles launched at an angle practice problems. So the first step for any of these is to draw the picture. So it says we have a bullet fired at an angle of 60 degrees with an initial velocity of 200 meters per second. So it tells us that our initial resultant vector, so not component, is 200 meters per second. And it's being launched at an angle of 60 degrees. I've got a better pen somewhere, I just can't find it. Try that again. There you go. All right, so in order to do this, you have to understand that what's going on. And it wants to know what the maximum height is. So what it's going to do is I'm going to do this in green. At the maximum height will be at the top of the arc. So at that point, our velocity in the y direction is equal to 0. And since it also wants to know how long the bullet is in the air, the time at this point is equal to 1/2 the total time. Because it's still going to have to come back down to finish the arc and land at some distance away. So first thing we want to do is we're going to find the velocity in the y direction. So that's going to be equal to, so velocity in the y direction is equal to 200 sine of 60. Velocity in the y direction ends up being 173.20 meters per second. And I'm not paying any attention to sig figs here. Since we know our initial velocity and we know our final velocity for 1/2 of the time, we can use our change of velocity is equal to the acceleration times the time. So change of velocity is always, delta anything is always final minus initial. So our final is 0 minus our initial, which is 173.20, is equal to the acceleration from gravity, which equals negative 9.8 meters per second squared times time. So you end up with negative on both sides, the negative goes away, divide both sides by 9.8, and we end up with a time value of 17.7 seconds. That's all you have to get to the midpoint, so that means our total time that the thing is in the air is twice as much, which is 35.3 seconds. Actually 35.4 seconds. So that's the first part. Wants to know what the maximum height is reached by the bullet. A couple of different ways you could do this. I think I'll switch to red. I'm going to use final velocity, which we know, squared is equal to initial velocity in the y direction, which we also know, plus 2 times gravitational constant times the height at which it has this final velocity. So we know our final velocity at the maximum height is equal to 0, is equal to 173.2 squared plus 2 times negative 9.8 times the height. We end up with 30,000 is equal to 19.6 h, and you end up with a height, maximum height of 1531 meters. All right, so let's go on to another problem. We have the coyotes being shot out of a cannon with an initial speed of 50 meters per second at an angle of 60. So 50 meters per second. He returns to the ground at the same level, so we're just making a nice even arc from which he started. How long is the coyote airborne? So we want to know total time. And it also wants to know what the maximum height is. So let's solve for time 1/2, because that's what it's going to be for the maximum height as well. So that's going to be the delta V is equal to gravitational constant times the time. And that'll be time 1/2. I'll just put that so I remember that. Talking about the change in the y velocity. So Vy is equal to 50 meters per second times sine of 60. So Vy is equal to 43.3 meters per second. So now we can solve it for the maximum height. Oh, we want to still want to solve it for the time, because that was the first part. So our final velocity is 0 at the top of the arc. Initial velocity is 43.3 is equal to negative 9.8 times the time at the halfway point. So divide both sides by negative 9.8, and you get that your T1/2 is equal to 4.42 seconds. So our total time is equal to 8.84 seconds. So that was the first part. Switch to blue. Wants to know the maximum height. So there's a couple different ways you could do it. I'm just going to stick with this one. So final velocity is 0 is equal to our initial velocity, which is 43.3 squared minus 2, or plus 2 times negative 9.8 times height. So you end up with So I didn't write down what the numbers are. I'll write them down, figure it out real quick. So 43.3 squared is 1874.89 minus 19.6 h. Solve for h, and you get that it is 95.7 meters to the top of that arc. So that would be the maximum height. All right, so continuing on. Now we got a hunter. He's practicing shooting, target shooting. Arrow leaves the bow at a velocity of 30 meters per second at an angle of 40. So we'll try my picture. The angle is 40 this time. Velocity is 30 meters per second. Wants to know the arrow's horizontal displacement. So how far does it travel in the x direction? So let's figure out the time to make the total time that's in the air altogether. So like before, so we're looking for our displacement, and at the halfway point, our y velocity equals 0. So dx is going to be equal to 30 cosine 40. Vy is equal to 30 sine 40. And Vy, since we're going to need that one right away, is 19.3. So our change of velocity is equal to acceleration times time, the halfway point, because that's the way we've been doing it. So we end up with, since final velocity is 0 at the halfway point, means our change in velocity is negative 19.3 is equal to negative 9.8 for acceleration due to gravity times time at the halfway point. And you get that time at the halfway point is equal to 1.97, which means our total time that it's traveling is twice that, so 3.94. All right, so it didn't ask us for the time. It wants to know the total distance that it traveled in the x direction. So velocity is equal to distance over time. So distance is equal to velocity times time. We know our velocity in the x direction is equal to 30 cosine 40. So this is Vx. Times our time. And we want the total time because we're talking about how far it goes in the 3.94 seconds. So distance in the x direction is equal to 90.4 meters. And so the last bit is to solve for the altitude at the halfway point. Again, there's a couple of different ways you could do it. Since we know the time, we could use the displacement and time and velocity expression. I'm just going to use this one again. So velocity final squared is equal to velocity initial squared plus 2 times gravitational constant times our altitude. At maximum height, velocity final is 0. Velocity initial works out to be in the y direction, 19.3. You square that, plus 2 times negative 9.8 times h. And I'm running out of space, so I'm just going to write down the answer. H ends up being the maximum height. I didn't solve it. So 19.3 squared is 372.49. Subtract that from both sides. And then we're going to divide by 2 and divide by 9.8. So we can get h by itself. And our h ends up being 19 meters. All right, so problem 4. You have a scared kangaroo jumping over a fence, and it's jumping with a speed of 8.42 meters per second. Angle is 55.2 degrees. They give us the time, for the total jump, because it tells you the jump lasts that long. So 1.4 seconds. That means that the time at the halfway point where you have the maximum altitude is equal to 0.7 seconds. You're jumping over a fence. We're trying to figure out what that height is. So we have to have at least whatever that maximum height is for this particular speed. So we're going to use the VF squared is equal to V initial squared plus 2GH. So at the top of the arc, the final velocity is 0. Our initial velocity in the y direction is 8.42 times sine of 55.2. We want to square that. Plus 2 times negative 9.8 times h. So you end up with, you solve for h, and you get that the height of the fence is 2.44 meters. It says, what was the kangaroo's horizontal displacement? So this is why you need to know the total time. I guess we didn't need the halfway time. So we have the, change colors. Velocity is equal to distance over time. We want distance. So distance in the x direction is going to be equal to velocity in the x direction times time. So our distance in our x direction is equal to 8.42 times cosine of 55.2 times the time, 7.40 seconds. So distance in the x direction works out to be 6.73 meters. All right, let's go on to the next one. Actually, for the last couple, I'm mostly just going to give you what the answers and the setup is. So, picture's pretty easy. It's at 37 degrees, 10 meters per second. And it wants to know the horizontal, so the x, and the vertical, y components of its displacement after 2.5 seconds. So time is 2.5 seconds. So when you do this, what you're going to find is that you're actually standing on the edge of a roof, so you know it's going to be lower. The answers you end up getting are that your position in your x direction is equal to 20 meters. So this total distance is 20. And then your position in the y direction is equal to negative 16. Which just tells you that it's 16 meters lower than where you started out. So down to here. is 16. All right, the next one, the picture is 250 meters per second at an angle of 35. And this is just a Vy equals, you're at maximum altitude, so Vy equals 0. You have an initial velocity, initial in the y direction, is equal to 250 times sine of 35. You want time, and your final velocity in the y direction is equal to 0. I already have that. You want time, so you're going to be using the delta v is equal to acceleration times time. And you're solving for at the top of the arc, so this works out to be what we've been calling t1/2. So the answers are the time to get to the top of the arc is 14.6 seconds. So the next one is another one about the coyote. 40 degrees, and you must clear a 50-meter high wall, and it wants to know what your initial total velocity is. So in this case, I would use the velocity final squared equals velocity initial squared plus 2AH expression. You know what H is, that's the 50. You know what A is, that's G. You know what the initial velocity is, that's just going to be the Y component. Find the final velocity, and then finally you know that, not cosine, sine of your angle is equal to the opposite, so velocity in the y direction, over hypotenuse. This you get from that. So you just solve for what the hypotenuse would be. That's a y. And then lastly, we have a bored kid. This is the one I really wanted to show you for the picture. So he's 30 meters away from a building. He throws a rock. It's asking where it hits the rock, where it hits the wall of the building. So your first step would be to find Vx. You know what dx is. Oops. So you want to solve for time. And then use you're looking for your height. Let's be consistent, so I'm going to use height is equal to initial velocity in the y direction times time, which you just found, plus 1/2 times gravitational constant times time squared. And that will tell you where it ends up hitting the wall. And you get an answer of, that your height is equal to 9 meters up.